Alright, let's get ready for our TEKS test. So I'm going to go through the TEKS review. I'm going to do a few problems from each section. Number 1 says find the exact radian measure of an angle given in degrees. So they want me to take each of these 3 problems given in degrees and they want me to change them to be a radian measure. So in order to change something to a radian measure, I'm going to multiply by pi over 180. So for each one of these, I'm going to multiply 100 by pi over 180, 285 by pi over 180, 450 times pi over 180, and I'm going to leave all my answers in terms of pi. So I'm going to just write in my calculator. I'm going to do 100 times pi over 180. So top times top is going to give me 100 pi. Bottom times bottom is going to give me 180. So all I have left to do now is divide the 100 by the 180. I can go straight to my calculator and do that. So 100 divided by 180, and then I'm going to math bracket, and we get 5 over 9. And I'm going to remember to leave my pi on top. So 5 pi over 9. And you're going to do the same thing for B and the same thing for C. On problem number 2, it says, find the degree measure of an angle given radians. So this time, I want to change it to be, each one of these radian measures to be in degree. So I'm going to multiply again. But this time, because I want it in degree, the 180 goes on top and the pi goes on the bottom. So I'll go do A again. So on A, we're going to take 14 pi over 9, and we're going to multiply it by 180 over pi. I'm going to remember that when I multiply, I can cross cancel, so my pi's will cancel out. So I have 14 times 180 divided by 9. I'm going to go straight to my calculator. I'm going to type in the numerator first. 14 times 180, hit enter, divide that by 9, and it's going to be 280 degrees. So on your TEKS test, make sure you know that if you're changing 2 radians, the pi goes on top, the 180 goes on bottom. If you're changing 2 degrees, the 180 goes on top, and the pi goes on the bottom. You need to go ahead and try B and C for both 1 and 2 and check your answers. Remember, all your answers are located right here on the back. All right, 3 and 4 are focusing on your understanding of what cosine and sine mean. The cosine value is referring to your x values, and when they talk about sine, it's going to refer to your y values. So on number 3, it says given theta as shown on the left, which of the following has the same cosine value as cosine of theta? So if I were to graph anything in quadrant 2 over here, my ordered pair would be a negative x, comma, a positive y. So they want to know which one of these, A, B, C, or D, also would have a negative x, because I'm just going to focus on the cosine. Well, right here for A, this angle is in quadrant 4, x is positive there. This angle is in quadrant 1, x is positive there. C is in quadrant 3, that's where x is negative. So that's the one I'm going to pick, because this ordered pair down here is negative, negative, and I want to know when my x's are going to be the same. They're both negative in C and the problem that they gave me. Number 4 is going to work very similar, except they're talking about y. So if I were to put an ordered pair right here in quadrant 4, it would be a positive x and a negative y. I'm focusing on the y value because we're doing sine. So I'm looking at each one of these answer choices, trying to figure out where will the y be a negative. And of course, the y is negative in quadrant 3, which is choice A. On number 5, they are asking you to find tangent, and they gave you some information. They told you that cosine is negative 12 over 13, and that theta is in quadrant 3. Because I'm in quadrant 3, I know that my x and my y are both going to be negative answers. And that's going to be important. They want me to find tangent. In order to find tangent, I know that the trig ratio is going to be the y value divided by the x value. So as long as I have y and x, I can find my tangent. they gave me cosine. Because they gave me cosine, they gave me the x and the r. I still have to go find y. We're going to use our formula for a circle. We're going to go plug in x squared plus y squared equals r squared. So I've got negative 12 squared plus y squared equals 13 squared. And I got those numbers from right here. Remember, the number on top is my x. The number on bottom is my r. The 12 happens to be a negative because it's in quadrant 3. Okay. So then I'm going to go and I'm going to get y squared equals, I'm going to subtract. So we get 13 squared minus a negative 12 squared. We get 25. So y squared is 25. So y is equal to 5. But I'm going to make it a negative 5 because, again, I'm in quadrant 3. So I know that my y is negative 5. My x is negative 12. So now I just have to plug in y over x. So tangent is going to be negative 5 over negative 12, which is equivalent to 5 over 12. A negative divided by a negative is a positive. All right, on number 6, name a possible radian angle of value theta for which cosine theta is equal to negative sine theta. And this is just going to refer back to exactly what we said on 3 and 4. Do you know that cosine means x and sine means y? So what they want to know is where on your circle does the x value equal the opposite of the y value? They want to know where on your circle does the x value equal the opposite of the y value. So if you think back to when we did our circle before, there was one place on our circle where the x's and y's were both the same positive number, and that was right here at pi over 4. And at pi over 4, we had root 2 over 2, comma root 2 over 2. And they don't want them to be exactly the same. They want the x's to be positive and the y's to be the opposite. So if this says root 2 over 2, they want a negative root 2 over 2. If this says negative root 2 over 2, they want positive root 2 over 2. So I know that my x's and y's are opposite signs in quadrant 2 and in quadrant 4. Over here, it's 3 pi over 4. And I'm going to have the ordered pair root 2 over 2, comma negative root 2 over 2. Positive, negative. Down here in quadrant 4, at 7 pi over 4, I have the ordered pair root 2 over 2, comma negative root 2 over 2. Again, same number, opposite signs. So our answers for number 6, we have 2. It's 3 pi over 4. And then the second answer we're going to go right is 7 pi over 4. All right, on number 7, it says, for each description, draw a picture and find the coordinates of the point where the terminal side of theta intersects the circle with the given radius. All they really want to know there is what is x and what is y. So I'm going to go find my x value, and I'm going to go find my y value. And I know in order to find x, I'm going to use r cosine theta. And in order to find y, I'm going to use r sine theta. So x equals 6 times cosine of 3 pi over 4. At 3 pi over 4, the x value, cosine, the x value is negative root 2 over 2. If I multiply 6 times root 2 over 2, I get negative 6 root 2 over 2. I'm going to divide the numbers on the outside, and I get negative 3 root 2. That's my x value. I'm going to do the exact same thing for the y value, except I'm going to use sine instead. Y equals 6 sine 3 pi over 4. So y equals 6 times, at 3 pi over 4, the y value is equal to positive root 2 over 2. I'm going to multiply. I'm going to get 6 root 2 over 2. I'm going to divide, and I get 3 root 2. So my final answer for my ordered pair is negative 3 root 2, comma, positive 3 root 2. And you're going to do the same thing for B, and you're going to do the same thing for C. 8 and 9 are trying to see if you remember about your amplitude and how to find your period. So the first thing I'm going to do is I'm going to go label this equation on number 8. The 3 out front is your amplitude. This number touching your X right here is called your B. It's your frequency. This number out here is my K, or I'm also known as my axis of wave, and a lot of people refer to that also as the y-intercept. So they want me to find the period of this equation. To find the period, we have to know that T equals 2 pi divided by B. So I'm going to do 2 pi divided by a half. Because you have a calculator, this shouldn't be a big deal. Just divide the 2 by the 1/2. So 2 divided by 1/2 equals 4, and then I'm going to put the pi back on it. So the period is 4 pi. The amplitude is simply the number that's located out front, so my amplitude is 3. So you're going to go ahead and try 9, see if you can get the right answer. Remember, the answers are located on the back. All right, let's go ahead and turn the page. Let's keep going. Number 10. So on number 10, they give me a picture of a graph. They want me to find the amplitude, the period, and write the equation. So 2 important things that I need to get off this graph. One is the amplitude, and my formula for amplitude, and you're going to need to know this, is you're going to take your max minus your min and divide it by 2. So my maximum y value is 6 minus my minimum is negative 2. And I'm going to divide that by 2. 6 minus a negative 2 is 8. Divided by 2 is 4. So my amplitude is 4. I also need to go find my axis of wave, or my K value. It's almost the same formula, except I'm going to add them. I'm trying to find the average. I'm trying to find the middle. So max plus the min divided by 2. So again, my maximum y value is 6. My minimum y value is negative 2. 6 plus negative 2 is 4. And 4 divided by 2 is 2. So this is my axis of wave right here at 2. They asked me for the period. In order to find the period, you're looking for where does one complete cycle. This happens to be a sine graph, and sine starts at the axis, maximum, axis, minimum, axis. So I had one complete cycle occurring at 2 pi. So my period is 2 pi. Now I'm going to go write my equation. When you write your equation, like we reviewed at the front, you write your amplitude first. The amplitude is 4. They want me to write a sine curve. Since my period is 2 pi, it's just going to be sine x. And I shifted my graph up 2, because that's my axis of wave. And there's my equation. Okay, you're going to do the same kind of thing on number 11. The only part I'm going to focus on 11 is part E, because I'm going to refer back to the equation that we did up here. It feels a little different on number 11E because there's no numbers. So they're looking for you to use the same formula, the max minus the min divided by 2. It's just going to be abstract. So hopefully we can all agree that this up here is the highest my graph goes. And the highest that goes, that order pair is R, comma, T. So I really only care about the T, the height of it. And this is the lowest part of the graph. And again, the only thing I really care about on this graph is the lowest part. So I just care about the Y value. I don't even care about the X value right now. I just care if the Y is U. So when I go plug into this formula, my max is T, because that's my highest Y value. My minimum is U, because that's my lowest Y value, and I'm going to divide them by 2. So you're going to see something similar to that. Just make sure that you're paying attention to when they ask you for amplitude, you're doing the highest point, focus on the Y value, minus the lowest point. Number 12 is the same kind of stuff, so I'm not going to go over that one either. Use the answer key on the back to check your work. 13, you're just reading a graph and answering a question. Again, use the answer key to check your work. Let's go look at 14 and 15. 14 and 15 is going over some vocabulary that we might have forgotten. When they ask you if something is even, they're asking you, is it symmetric to the y-axis? If they're asking you if something is odd, they want to know, is it symmetric to the origin? And every time we talked about it being symmetric to the origin, I always said, remember, it's like a double flip. You flip it over the y, you flip it over the x, and then it lands on itself. So the cosine graph is the one that kind of looks like the tulip. And I could take this right side and fold it right over, so I could fold it over the y. So this one isn't even. My sine graph, we just looked at a sine just a second ago, looks more like this. And if I were to fold this right there in the middle, it doesn't lie on top of itself. This one's odd. Tangent is the weird looking graph. It kind of looks like this, and it's got the asymptotes on it. This one is also odd. Okay, so you go try D, E, and F, and again, check the answers at the back. On 15, they're asking you which of these above are continuous. It is continuous over real numbers if there are no asymptotes. The only two graphs up here that don't have asymptotes are y equals cosine x, which happens to be choice A, and y equals sine x. Every one of the other graphs has vertical asymptotes in it. On number 16, A, B, and C, they want you to find the area of a sector. To find the area of a sector, you're going to have to know the formula. There were two formulas, one for radians and one for degrees. I'm going to do the degree problem right here at the end. The area is theta pi r squared over 360. So I'm just going to go plug in. Area equals 315, that's my theta, times 5 squared times pi. I'm going to leave my pi right there at the end, all divided by 360. Now they are not going to leave the answer in terms of pi, so this time when I type it in, I'm actually going to type in my pi button. So 315, oops, let me make sure I'm in degree mode. I am. I want to be in degree mode because right here, this is in degrees. So I got 315 times 5 squared times pi, enter, so that's my top, that's the numerator, divided by 360, and we get 68.72. We're doing area, so it's inches squared. Okay, and you're going to do the same thing for A, and you're going to do the same thing for B. But notice on these two, your formula should not be the same formula because these are not in degrees. On 17, A through I, all you have to do is go look at your unit circle to answer the questions. So I'll pick one of these to do. I'll do 17A. So you go to your unit circle at pi over 4. So pi over 4 is located right here in quadrant 1. And at quadrant 1 at pi over 4, we have root 2 over 2, comma root 2 over 2. They want to know cosine. Cosine means x. My x value at pi over 4 is root 2 over 2. And you do the exact same thing for the other problems. You just have to make sure that you go back to your unit circle and check things out. For cosine, you're going to write down your x's. For sine, we're going to write down our y's. For tangents, we're going to divide the y's by the x's. You have to remember when you do cosecant, cosecant is the reciprocal to sine. So you're going to take your y value and you're going to flip it. Tangent, y over x. Secant is the reciprocal to the cosine. So you're going to take your x value and you're going to flip it. Sine again is y, and cosecant again, you're going to take your y value and you're going to flip it. So pull out your unit circle, go back and check these, and check them on the back to make sure you don't have any questions for your teachers. On 18, 19, and 20, all these have something in common. They have this little negative dude up here. That means sine inverse. So this one's going to work the opposite of the ones above. On these problems, they want to know where on your circle does x equal negative 1/2. Well, I know that x is negative 1/2 over here in quadrant 2 at the top at 2 pi over 3. I could also call that 120 degrees. To do this one in your calculator, you get the 120 in your calculator. If your calculator's in degree mode, you just go type in second cosine, negative 1/2, and it'll pop out 120 degrees. So if you aren't sure how your unit circle, you could do it in degrees and get 120, and then you could go back and convert 120 degrees into radians by multiplying by pi over 180. So that's another way to do it. On 21, A, B, and C, they're just trying to get you to figure out which quadrant you're going to be in. So on 21A, they're saying where are my sine values greater than 0? That means where my y is positive and my cosine value is less than 0. X is negative. So where on your circle do you have a negative x and a positive y? Right here in quadrant 2. And you're going to do the same thing for B and the same thing for C. On 22, they're trying to see if you remember any of your trig identities and how to simplify. So on 22A, I'm going to rewrite sine theta times cotangent theta as sine theta times, I know that cotangent is really the same as cosine over sine. And now that I did that, I can put the sine over 1, I could cross cancel, and the only thing left is cosine theta. Okay, I'm going to go do C with you also. So on C, the first thing I'm going to do is multiply these two together. So I'm going to write sine squared x plus, if I go multiply these, I'm going to get the same answer we got over here. See how it says sine times cotangent? This says cotangent times sine. The only thing difference is these are squared and these are not. So if I go cotangent times sine, I'm going to get cosine squared. And then I remember one of my trig identities, sine squared plus cosine squared equals 1. On problem number 23, A, B, C, and D, they're trying to see if you remember your sum and difference and your double angle formulas. They will give you those formulas on the test, so don't stress too much. You just have to know how to use them. So I'm going to go look at letter D. This matches a double angle formula, and in my double angle formula, I can go rewrite this as sine parentheses 2 times pi over 8. I know 2 times pi over 8 is the same thing as sine of pi over 4. And I know at pi over 4 that my y value, because sine means y, is root 2 over 2. Alright, on 24, they want to see if you know all of your identities, your reciprocals, your quotients, and your Pythagorean identities. I'm going to just focus on the Pythagorean with you. Pythagorean identities, the first one we learned was sine squared x plus cosine squared x equals 1, and we called this our Phineas and Ferb because we thought about when we were younger and we watched Phineas and Ferb. He had the triangle head, and that reminded me of a squared plus b squared equals c squared. The second one that we learned was I tan and a second, so 1 plus tangent squared x equals secant squared x. I tan and a second. And the last one was I cut cheesecake, so I cut cheesecake. And these are my 3 Pythagorean identities. You will need to know those for your test. On number 25, it says name 2 angles coterminal with each of the following. If they want you to do coterminal and it's in radians, you're going to add 2 pi and you're going to do it again, but you're going to subtract 2 pi. So on A, you take pi over 3 plus 2 pi and get an answer. And then you're going to take pi over 3 minus 2 pi and get an answer. And you're going to do the same thing for B. When you get to C, because it's in degrees, instead of doing 2 pi, you're going to add 360 and then you're going to do it again, but you're going to subtract 360. 26, A and B, want to see if you remember how to graph your tangent inverse and your sine inverse. So our tangent inverse, we just take our normal tangent curve, and we're going to lay it on its side. Go ahead and try B and check it on the back. The only other thing I can think of that we need to make sure you go over for your test is make sure you know your SOHCAHTOA, and that anytime you have to solve a triangle problem, make sure you're in degree mode. Other than that, finish the rest of the review on your own. Remember to check all your answers on the back and make sure to ask me questions in class. Good luck!